So we have this concept in the ESB of a service having an action chain. I'm just simply mentioning that now because you'll see more of that later. But a single service has a series of steps within it. Each step represents a specific mediation point. So the first mediator in this case might be a transformation. You might even have a secondary transformation, CSV to XML, XML to POJO. Because typically in a Java world, we want POJOs at the end of the day because we can persist those, we can operate business logic on them. I might have a router or a splitter. I might invoke a BPM solution. I might have to log it, wiretap it. But these are all different steps in that mediation process. So each of these guys specifically shows up to do additional logic, not business logic necessarily, but just to perform mediation against that inbound data. Okay? The last step over here is, of course, my business logic component. So once I've massaged the data to what I want it to be, I then can persist it through my enterprise Java beans. I can invoke an external web service. I can simply run additional POJOs which represent my logic, let's say Spring-based POJOs or something of that nature. Services and actions can have this relationship. So you can have a single service with a series of steps, series of actions within it. And then a service can route to other services as well. So this concept of complexity of having a federated environment where I have multiple services interacting with each other to solve a specific problem. And I make a point here of talking about the enterprise integration patterns. You can see there's things like splitter, aggregator, translator, router, recipient list, process manager. These are things we focused on when we created this architecture and created this infrastructure. So this is an important book. I'd encourage you guys all to go read and review. And it'll give you a good idea for what's going on inside our environment. At the highest level, I like to use this chart to kind of illustrate what this thing can do. You can look at the left-hand side here. We have the concept of transport mediators, right? So by default, these guys are our gateways. They receive data from outside world. Think of them as little event listeners, listening in on specific types of transactions in the world. Maybe it's an HTTP endpoint, FTP, JMS, pretty obvious for JMS, file drop, email, SQL. So this is if a record changes in a SQL database. We even have one for Hibernate. Hibernate has an event model. So as the event model or the domain model within Hibernate changes, those can be events emitted into the ESB and responded to by the ESB. JCA inflow, socket, SOAP. SOAP is an obvious one. Most people think in terms of SOAP when they start thinking in terms of ESB, but we're not focused on it necessarily. So web services is one way to actually cause the ESB to execute. We also have a scheduled service, a time-based service that runs whenever you tell it to run. We have this NVM one, which is an optimized transport. So in other words, if we know we're in the same JVM, don't serialize this thing to XML and run it over SOAP. Just simply run it directly, as an example. Once you have received the data, received the input, if you look at the middle part of the screen here, we then have these different mediation tools that can be applied. I can transform it, route it, secure it, manage it. I can put it in a registry, I can store it, I can orchestrate it with JPDL or something of that nature. And then on the far right-hand side of the screen, these are just various ways to build up your technology. So if you want to do custom coding, you can do things like using, you can write a Spring component, you can write a Groovy component, you can write an EJB. You can actually invoke another web service. Let's say you have a .NET web service out there that you want to proxy into this solution. So there's a lot of tools that you have access to out of the box with the JBoss ESB. Okay? So let me show you a demonstration, and then maybe it'll make some more sense. So what I have here is the J Pet Store. If you download the Spring Framework, it actually comes with this Pet Store application. And the reason I use the Pet Store is because it represents a standard siloed application. Everything you guys have probably done up to this point when it comes to learning things like Spring and Struts and Hibernate, or learning things like Seam even. I have another demo that uses Seam. Pretty much you've always built new silos. If you built a .NET application, you built a new silo. If you built a LAMP, Linux, Apache, MySQL, you built a new silo. Almost everybody is trained from the very get-go to build a new siloed application. You don't think in terms of interoperability with existing systems in many cases. So what's interesting about this example is we use Spring AOP, aspect-oriented programming, to hijack the order out of the Spring system. So the Spring code isn't even aware that we're eavesdropping on it. So we're basically snatching an order out of it and then routing it through our business process and our business rules. Right? So we can apply common business rules. So when I submit my order in the Pet Store application, it'll actually come down here and execute a specific set of business logic. It'll start my business process. It'll go to intake order, which has some Groovy code and a Smooch transformation component. It'll run business rules against it, declarative business rules from Drools. It'll then be available to review. So there's a little task manager I'll show you. The user can then review the order. They can approve the order. It'll then run a discount calculation, again, business rules. It then have a review discount step in the status, all right, in the task manager. And then of course I'll go to shipment. And so I'll show you what this demo looks like, but this slide kind of sets it up. All right. So let's get this application running. So here it is inside the IDE. This is an Eclipse-based plugin environment. This is, of course, JBoss Tools, or JBoss Tools from jboss.org, and otherwise known as JBoss Developer Studio, which is a specific version that I'm running here. And then I have my engine running over here. All right, typical engine, that's what it looks like. Nice black on white, or excuse me, white on black. Very attractive. Typically an engine doesn't look all that great, but that's my ESB server environment based on the JBoss application server environment. And what else do I have here? I have my browser environment running. Okay, so here is the pet store application. We're going to add a couple of these guys to the cart. Let's order 10 of them. Okay, proceed to checkout. Continue, and there's nothing different about this application. If you download it with the Spring Framework, it's the exact same application. The only difference is that when I actually submit the order here, okay, there's an order number that shows up, 1030. And if you notice on my server now, there's things that are ongoing, right? There's work that's happening here. And specifically what's happening is that 10030, right, is now flowing through our system. If I go over to my JBPM console now and click on this order process, you can see there's 10030 running. So the order 10030, right, or 1030 running. If I hit examine and process image, you can kind of see what the process is in flight. Now this is persistent. It's a state information that's held in the database. If we reboot the server right now, it'll still be at this exact same point. And it's waiting for a user now to come in and review that order and look at it. If I look at my process variables here, you can see there's all the data that came out of that Spring-based application, including the original whole XML and parts of the data that got broken out into individual pieces that I care about, like $185 for the fact that it's 1030. Okay? So if I come over here, and let's just go back to this guy here, and I want to click on tasks, okay, and hit examine, I can hit save and continue, all right, and now if I go back to my process instance and the image, you can see it went from review order to calculate discount to review discount. And you can see that this little monitor guy, which is simply eavesdropping on the process flow, simply says, okay, the discount service calculated 14.9, right? And now here it sits again. If I click on task, examine, I can approve that. All right, so it's been approved. And if I click back over here, and the image, you can see it's waiting for shipment and close. Now what's interesting about this, again, keep in mind that the ESB is backing up each of these nodes. So everything you see here, there's an ESB component behind that. All right, and I'll show you some of the source code in a second. But what it's doing is it's now waiting for an external event to ship and close. Because in this case, our business is to have a third-party business partner which is responsible for shipment. They handle all the warehousing for us. We don't handle any warehousing ourselves. It's our product, but they handle all of that for us. So I have to send them a notice. And I have to wait for them to give me a notice back, some sort of shipment notice to let me know that that shipment has left the building and it's on its way to my customer. So it's going to sit here indefinitely. So let's hit refresh here. Okay. So it's just sitting here at this point. And what it's sitting on and waiting for is the shipper to come back with a specific transaction. In this case, it is actually a file that shows up on my hard drive. And I purposely put it in the wrong place. So if I move the file to the right location, okay, so I move it to the right location, now it goes to end. So in this case, the ESB is watching that specific file folder, and again, that's another event into the bus, and then of course the bus is driving the BPM solution. So all these things are interconnected, and we'll show you how that works here in the IDE.